So we need to find the power output in order to maintain a speed of 3.8 revolutions per second. So we have our mass is simply going to be equal to 220 kilograms. And then our radius is going to be 5.5 meters. Our omega is going to be 3.8 revolutions per second. We're going to convert to 7.6 pi radians per second. And then we have delta t is going to equal 16.0 seconds. So we need to find power. Power is going to be equal to tau omega initial, or rather just omega. And tau, though, is going to be equal to I alpha. So in this case, alpha is actually, well, we can say that P equals I alpha omega initial. But in this case, alpha is the angular acceleration needed to essentially stop the rotor in 16 seconds. So alpha will actually equal omega final minus omega initial over delta t, and here omega final will be 0, so this will be negative 7.6 pi divided by 16, and we have negative 1.492 radians per second squared. So this would be as if an angular acceleration was stopping the centrifuge in 16 seconds from 7.6 pi radians per second. However, when we're calculating power in order to maintain a speed of 7.6 pi, we're going to have to maintain a power such that the power counteracts the frictional torque. Because this angular acceleration, this negative angular acceleration here is simply caused by friction. So if we overcome friction, and we have no other forces affecting the rotor or the cylinder, we're going to actually obtain the power needed in order to maintain 7.6 pi radians per second. So we can also say that the moment of inertia of the cylinder is going to be equal r squared over 2. And at this point, we can solve for P a little bit more and say that power is going to be equal to mr squared alpha omega initial, rather just omega, over 2. Now, this alpha is going to be positive. This alpha is going to be positive because that's the angular acceleration that we have to overcome due to friction. We calculated that here. So here, this is going to be positive because we want to counteract friction. So this is going to be 220, and then r will be 5.5 squared, and then alpha will be 1.492 positive, and then this will be 7.6 pi, all divided by 2. And power equals 118,535.92 watts. This is going to be times 1 horsepower over 746 watts. So 1 horsepower is equivalent to 746 watts. So converting this to horsepower, we have that the power equals 158.895 horsepower. This will be the final answer. And that is the end of the solution. Thank you for watching.